Hi guys, only 3 more Mondays to go, really more like 2. I want to take you through what we talked about late last week, and if this is the first video you're watching, I highly encourage you to watch the previous videos from Thursday and Friday to help you out. So anyway, what I drew here on the top was I drew a carbon chain that is 1, 2, 3, 4, 5, 6 carbons long. So according to table P, 6 is hex. So you should have your reference tables out or looking at them online. Easily enough, you can just Google search chemistry reference tables. Because all the bonds between the carbons are single bonds, it is an alkane, therefore it ends in -ane. So the name of this structure is just hexane or N-hexane. Now what we talked about is any hydrogen can be substituted for any of the following, and this is all on table R. So a hydrogen can be substituted with halides, so a Br, which is named bromo, which is on table R, a Cl, which is chloro, an I, which is iodo, and F, which is fluoro. So any one of those hydrogens can be substituted with those, or they could be substituted with something called an alkyl group. Now alkyl groups are carbon groups. CH3 is one of them, and that is called a methyl group. Sometimes you're going to see it drawn out, a methyl group like that, which just means they're drawing the structure instead of the condensed formula. Same thing, a hydrogen can be replaced with an ethyl group, and if you draw out the structure of the ethyl, there's the CH2 and there's the CH3. So you can see it either way. I like drawing the condensed just because it is a little bit less, it takes up less space. So in order to name a organic compound, if it has a substituent on it, which are those above, you must note the location by the carbon number it is attached to. So, for example, if I just redrew a hexane, if I take away this hydrogen, and let's just say I take away this hydrogen, and let's make it let's just say I put a bromine here, a Br, and then let me put a methyl group here. I can't just call this methyl bromo or bromo methyl hexane because those could move all over the molecule and change properties. So the location determines the properties. So when I name this, because these guys are towards the left side of the molecule, I want to make sure I always give them the lowest carbon number. So 1, 2, 3, 4, 5, 6. So the way I would name this is I would name it in alphabetical order. So I start with a 3 because that's where the bromo is attached to, 3-bromo. And then the methyl group is attached to the second carbon, so 2-methyl, whoops. And then my parent, because it's 6, is hexane. The other thing that we talked about is if there are, let's just say I put another let me erase something and put another bromine here. So now I have another substituent. So the way I would name that is every single substituent needs its own carbon number. Because now I put 1 on the first, I would say 1, 3, and then I would say dibromo because there's 2-methylhexane. Okay, the last thing I want to talk about on this, before I switch to alkenes and alkynes, is that I can actually, if I draw I can draw the same exact structure backwards. So I'm just going to use this name, and I'm going to erase these numbers that I drew. And I'm on the first carbon, again, it doesn't matter where. I'm just going to, let me just put a bromo here, and then I'm going to erase this and put another bromo there. And I'm going to erase this and put a methyl there. So notice, because the substituent, it's just another way that this can be drawn. So I wouldn't draw it this way given the name, but you might see it this way. So because most of the substituent groups are on the right side of the molecule, remember these molecules flip all around in space. They're not like read left to right, right? They're always moving around. So what I would do in this case is I would number it this way: 1, 2, 3, 3, 4, 5, 6. So I would have the exact same structure, but it's like the mirror image of that structure, which is also acceptable. Okay, and then lastly, I just want to review alkenes and alkynes. The only thing about alkenes and alkynes are they have a, alkenes have a, sorry, I can't spell this morning. Alkenes have a double bond and alkynes, there we go, have a triple bond between the carbon atoms. So if you have something like C double bond, you need to give that double bond a location. So if the double bond is on the second carbon, you would write, in this case would be 5 carbons, it would be 2-pentene, because it's an alkene. If I erase that and I put that on here, then I have to erase some of the bonds, because remember, carbon can only be surrounded by 4. This now would be called 1-pentene. And again, go back to the other videos if you missed some of them. Okay, alkynes, the same idea. So for an alkyne, we would put a triple bond. I'm just going to make this a long carbon chain. And then we would name it and give it a number. So I could actually count left to right or right to left. I'm still going to end up with the same carbon number. So for example, if I said 1, 2, 3, 4, and so on, 5, 6, this would be called 3-hexyne, because it has that triple bond. And the 3 is the location. So just because the triple bond is between the third and the fourth, you use the lower number. Now if I counted backwards here, I would still get the same carbon number. So 1, 2, 3, 4, 5, 6. So this would be still 3-hexyne. So the things that you have to watch out for, whoops, sorry about that, is if you have something like this, this is actually going to be called 1-butyne, because we would count it right to left because we want that double or triple bond to have the lowest carbon number. So this would be called 1-butyne. Okay, so for your homework, I'm going to give you 5 names and have you draw the structures, take a picture, and submit to me. Have a great day.